Today we're going to learn how to expand and condense logs, and that's going to help us later on when we're solving. So we'll start out with talking about this. You can only expand or condense logs when the bases are the same. So when it's multiplication, we're going to split it up with addition. So here's an example. The log of 15 times x, multiplication, is log 15 plus log x. Multiplication becomes addition. Division becomes subtraction. Log of 3 divided by x is log 3 minus log x. And the third rule is the exponents become coefficients. So if it says log of x squared, the exponent comes out to the front and becomes a coefficient. All right, let's practice that and see how that works. So the first one, notice this is multiplication. We're going to pretend like there's parentheses around these. So we're going to split that up. Multiplication becomes addition. So we're going to say log base 3 of 5 plus log base 3 of x. Let's do number 2. This one has an exponent. So remember, the exponent is going to come out in front and become the coefficient. So this one is 3 log base 6 of x. The base didn't change, the x didn't change, but the exponent became a coefficient. Next, we've got log base 7 of 8x to the 4th. So we're going to split that up into log base 7 of 8 plus log base 7 of x to the 4th. Now you might notice, well, I have an exponent on this one. Aren't I supposed to pull that out in the front to be the coefficient? Yes, you are. Notice it's only the coefficient in front of the log base 7 of x, because the 4th power only went to the x, not to the 8. So we'll say log base 7 of 8 plus 4 log base 7 of x. That would be our answer there. All right, we've got division here, and we have multiplication. So for multiplication, remember, we're going to add. For division, we're going to subtract. So this one will say log base 3 of 3 plus log base 3 of x. And since y is on the denominator, it's being divided, so it gets a minus log base 3 of y. So addition came from multiplication, subtraction came from division. All right. Now this one says natural log, but everything else about it is the same that we've been doing. So on my numerator, I've got 5 times x to the 3rd. So I'm going to say natural log 5 plus, remember, just like in number 3, the exponent was going to become the coefficient. So I'm going to go ahead and move my exponent to be 3 natural log x. Now, these are both on the denominator, so we're going to subtract each of them. Minus natural log of 3 minus natural log of y. So on the numerator, they're multiplying, they get added. On the denominator, we're subtracting. Now, technically, we did this because the 3 and the y are multiplying on the denominator. And so we subtracted these that were being multiplied together. If you distribute that negative, they end up both being negative. So you could do that either way. Now, let's take a look at this one. What does it mean when I have the cube root of x to the 4th? Can I write that as just x to a single exponent? Do you remember our fractional exponents? The numerator is the power, the denominator is the root. So what this is really saying is natural log of x to the 4/3. And then just like before, our exponent comes out in front to become the coefficient. 4/3 natural log of x. Now number 7 looks a lot like number 5. So we're going to take our numerator and we'll say log 5 plus, remember x to the fourth, the 4 becomes the coefficient, 4 log x. And on my denominator, I'm subtracting, because that's division, minus 3 log y, because the exponent became the coefficient. So that's how we expand our log expressions. Next, we're going to condense our log expressions. Now, condensing is what we just did. Addition becomes multiplication, subtraction becomes division, coefficients become the exponents. So it's the reverse of everything we just did. So take a look at this one. It says natural log of 7 minus natural log of x. So we're going to combine those into a single log expression. Subtraction turns into division. So I'm going to say this is the natural log of 7 over x. 7 divided by x. Now let's take a look at this one. I have a coefficient of 3. My coefficient is going to come up here and become the exponent. Same thing with the 7. And notice that it was addition. So inside my log expression, that turns into multiplication. Log base 5 of x to the third times y to the 7th. Addition became multiplication. Coefficients became the exponents. All right, let's take a look at the next one. 2/3 natural log x minus 3 natural log y. So subtraction is going to become division. Natural log. On my numerator, I have x to the 2/3. And on my denominator, I'm going to have y to the 3rd power. Now, what's another way I could write x to the 2/3? Couldn't I write that as a radical? Remember, the denominator is the root, and the numerator is the power. So I could write it just like that. All right, number 11. I've got 3 expressions here, and they're all log base 4. So my answer is going to be a log base 4. And I have addition. These are going to be multiplied. And I have a subtraction, so that one's going on the denominator to divide. So first off, I have 10. And because this one says 3 log base 4 of x, my coefficient becomes the power. So that becomes x to the 3rd. And this is subtraction, so this is the division part on the denominator. My coefficient becomes the power. And I'm done. Now this one's interesting. Find the log base b of AC if I know log base b of a is 7 and log base b of c is 3. So my first thought is, can I expand this into 2 log expressions, log base b plus log base b? It's multiplication, so log base b of a plus log base b of c. I expand it, and then I'm just going to substitute. Since log base b of a is 7 and log base b of c is 3, my answer here is 10. So all I needed to do was expand it and then make substitution. Number 13 is very similar. I know that the natural log of 5 is 3. How can I find the natural log of 25? Can I write 25 using a 5? Here's what I'm thinking. Isn't 25 the same as 5 to the 2nd power? And then according to my log rules, the exponent comes out here to become the coefficient. So that's really saying 2 natural log of 5. Well, since the natural log of 5 was 3, this question is asking for 2 times 3. So all in our lesson today, we're going to be practicing expanding and condensing our logs.